Hey there, this is Miss Moyer with 14.5 using the Pythagorean theorem. In this lesson today, this is part 1, we will be determining if a triangle is in fact a right triangle just based on its side lengths alone. So a word we're going to use today is the word converse. And when you think converse, maybe this is what you think, a classic sneaker. However, in math, we're going to use the word converse a little differently. So in math, we use this word converse around if-then statements. So you'll see that this that I wrote here is an if-then statement. It says, if you wear old shoes, then your feet stink. So maybe you agree with that, maybe you don't. But we're going to talk about this if-then statement and the word converse. So the converse of an if-then statement would look like this. So if your feet stink, then you wear old shoes. Maybe that's true, maybe that's not. It's still an if-then, but you'll notice we switched the order. So the first part here and the second part got swapped in the other statement. So that's what converse is. So when we talk about converse in math, we're talking about taking something we know to be true and switching it. Sometimes they stay true, sometimes they're not true anymore. So the Pythagorean theorem says that if a triangle is a right triangle, then a squared plus b squared equals c squared. But the converse looks like this. If the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then it must be a right triangle. So before we were saying, look, if it is a right triangle, you can use this to find a missing side length. The converse is saying, if you can get the Pythagorean theorem to work, then you're proving that this is in fact a right triangle. So for example 1, we have to prove whether these triangles are right triangles. First thing you need to know, you need to remember, the hypotenuse is always the longest side of a right triangle. So for A, we've got 3 side lengths, 9, 40, and 41. So that means that this 41, if this is a right triangle, that's the hypotenuse, or C. So that makes 9 and 40 are legs, A and B. So I need to check to make sure that these side lengths will satisfy the Pythagorean theorem. So I'm going to plug in the numbers that I know. So I'm asking, is 9 squared plus 40 squared really equal to 41 squared? So I did out all those squares, and we find out that 9 squared is 81, 40 squared is 1,600, and 41 squared is 1,681. So when we add up the left side, we get something that's true, which means this is a right triangle. For B, you may look at it and say, hey, I can look at that and say it's not a right triangle because it doesn't look that way. But you still have to prove it. So again, you look for the longest side. This is the longest one, so that has to be C, making the other two the legs, A and B, whichever order you like. So if this is a right triangle, then 12 squared plus 18 squared has to equal 24 squared. So I did all the math out, and I got 144 plus 324 is supposed to equal 576. And already I can see that looks a little fishy because 4 plus 4 isn't going to give me that 6. But I will keep going to really show that this is not true. And I see that 468 is not equal to 576, so this is not a right triangle. So now you give it a try. You see if each of these makes a right triangle. Remember, the longest side has to be the hypotenuse. Pause the video and I will be back in a second with the answers. And so here you can see the first one turns out to be not a right triangle and the second one is. I did something a little weird and I changed those decimals in the problem into fractions. It made the numbers a lot easier. I bet a lot of you didn't do that, so I will take a second and redo the problem with the decimals in case that helps you out. Okay, so you can see what a pain this other math is to leave them as decimals. So nice tip, whenever you have decimals that are pretty easy to convert to fractions, if those decimals are annoying like these, 1.25 and 0.75 to square, converting them to fractions can make your life a lot easier. All right, that's it. Your assignment is page 660, numbers 5, 7, 9, and then 27 through 30. Have a great rest of your day.